Hello dear students, I welcome you all for this session on antioxidants. The learning objectives of these sessions are: at the end of this video you are able to define antioxidants, you are able to describe or discuss the mechanism of action of antioxidants, you are able to choose ideal properties of antioxidants. Observe the image which is present in on your screen. See the difference between these two images. See, this is the apple. After cutting the apple is get change its color into the brownish color after some time. Why? This is because of the oxidation of this apple. When an apple is cut, oxygen is introduced into the injured plant tissue. When oxygen is present in a cell, polyphenol oxidase enzyme in the chloroplast rapidly oxidize phenolic compounds naturally present in the apple tissues to O-quinone, colorless precursors to brown colored secondary products. Quinones then produce the well-documented brown color by reacting to form compounds with amino acid or proteins, or they self-assemble to make a polymers. So because of that, due to the oxidation of this apple, it get converted into the brownish color due to the formation of quinones. Then another image is in front of you, that is fresh oil. After storage of some days, this fresh oil is get converted into the blackish color, or the obnoxious odor is observed in the oil. So this is the rancidity of oil, and rancidity of oil is caused due to the oxidation of fresh oil. There are number of reactions are takes place. There are two reasons because of the rancidity is takes place: due to the oxidative reaction or the hydrolytic reaction. So these are the well-known examples of oxidation. So now we'll discuss about the antioxidants. Antioxidants, these are the agent or the compounds or the substances. These are added in any pharmaceutical preparation or in an active pharmaceutical ingredient to inhibit or to prevent the oxidation of ingredients and subsequent deterioration of the product. So let us see what is antioxidant. Anti means against, means that is the opposite reaction or opposite action. Oxide means oxidation or the oxidation reaction, and ant means anti means agents. Antioxidant means the agent which is act against oxidation. So first of all, we must have to discuss what is oxidation and what is reduction. So first of all, we discuss about the oxidation. Oxidation is the reaction in which the addition of oxygen or the removal of hydrogen or the loss of electron takes place from a compound. This reaction is called as the oxidation reaction. Or reduction means what? Reduction is defined as the removal of oxygen or the addition of hydrogen or the gain of electron from a compound. This is the reduction. So the exactly opposite reactions takes place in the reduction as takes place in the oxidation. See here, in oxidation the addition of oxygen takes place, and in reduction removal of oxygen takes place. In oxidation removal of hydrogen takes place, and in a reduction gain of hydrogen is takes place, or the addition of oxygen hydrogen is takes place. Sorry, addition of hydrogen is takes place. In oxidation, loss of electron is takes place, and in a reduction gain of electron is takes place. So let us see the reaction. See here, from oxidation loss of electron is takes place, and after gaining this electron reduction is takes place. Simply oxidation is loss of electron and reduction is gain of electron. So now we will discuss again the definition of antioxidants. Antioxidants, these are the agent or the compounds or the substances. When these are added in any pharmaceutical preparation, these are inhibit or prevent the oxidation of ingredients and their subsequent deterioration of the product. Chemically, these antioxidants are act as an reducing agent. Reducing agent are the agent. These are reduce the other substance by oxidizing itself. Means when the loss of electron may takes place from the active pharmaceutical ingredient, this substance means active pharmaceutical ingredient is reduced by these antioxidants, and whatever the loss of electron which is takes place by oxidizing itself from this substance, they are get oxidized, means loss of electron is takes place from these antioxidants, and this electron is gained by the oxidized active pharmaceutical ingredient. So the examples of antioxidants are, there are various examples of antioxidants. These are nitrogen, sodium metabisulfite, sodium bisulfite, hypophosphorus acid, sulfur dioxide, sodium nitrite, sodium thiosulfate, etc. Then classification. Mainly antioxidants are classified into two types: organic antioxidants and the inorganic antioxidants. Organic antioxidants are quinol group, like a tocopherol, hydrochromins, hydroxycoumarins. These are the organic antioxidants. Then pyrogallol group, amyl gallate, N-propyl gallate, these are the pyrogallol group. Amines, organic antioxidant, these are the cephalin, lecithin. Then benzoic acid derivatives, like a benzoic acid derivatives like esters of para-aminobenzoic acid as methyl or propyl paraben. Then inorganic antioxidants, these are the nitrogen, sodium metabisulfite, sodium bisulfite, hypophosphorus acid, sulfur dioxide, sodium nitrate, sodium thiosulfate, etc. So now we will discuss the mechanism of action of antioxidants. The antioxidants are acted by two different mechanisms. It may act by oxidize in place of, means antioxidants are oxidized in place of the active constituents. They are oxidized itself and prevent the oxidation of the active pharmaceutical ingredient, that is API. And they may be acted by, if active constituent is oxidized, the antioxidant are reduced it back to its normal oxidation state. So these two, by these two mechanisms, these antioxidants may act. So now we'll discuss. Inorganic antioxidants are act by redox reaction. These inorganic antioxidants are act by the redox reaction. Redox reaction means where the loss of oxygen and gain of oxygen, loss of electron or the gain of electron, both the reactions are takes place simultaneously. This is the redox reaction. In redox reaction, there is a transfer of electron from one compound to another. Since oxidation is the loss of electron from a chemical species and reduction is the gain of electron, the overall reaction can be shown as like that. See here, in oxidation, the loss of electron is takes place due to the loss of electron, oxidation is takes place, and when this electron is gained by this substance, the reduction is takes place. When a substance acts as an antioxidant, this is the reducing agent, it gets oxidized itself and prevents the oxidation of the active pharmaceutical species. A strong antioxidant will protect the material when used in a small amount and for a longer period. The inorganic type of antioxidant basically act as a reducing agent. They are used in a pharmaceutical preparation containing easily oxidizable substances to protect them in their original form. The antioxidant usually prevents the oxidation of active compounds and in place of get oxidize itself. Simply the redox reaction takes place in the mechanism of action of antioxidant. They are oxidized itself in place of active pharmaceutical ingredient, and if the substance is already get oxidized, then they are reduced this substance and by oxidizing itself. So this is the mechanism of action of antioxidants. The next is the ideal properties of antioxidants, or this is the criteria for the selection of antioxidants. First, antioxidants and its reaction product should be harmless or non-toxic. Second, it should be effective in a low concentration. It should be physically and chemically stable. It should not produce any solubility problem with the drug or any other component in the preparation. It should not cause any incompatibility problem physiologically and chemically with any ingredient of the preparation. It should not give color, odor and taste to the product. It should not interfere in pharmacological activities of active pharmaceutical ingredient, and it should not change the pharmacokinetic or the pharmacodynamics of the drug. So this is all about the ideal properties of antioxidants or the criteria for the selection of antioxidants. So please learn these drugs and their monograph: hypophosphorus acid, sulfur dioxide, sodium bisulfate, sodium metabisulfite, sodium thiosulfate, sodium nitrate, nitrogen gas. These are the inorganic antioxidants, and you have to learn these things from the monograph, name and the synonym, if any, of that particular substance, then their molecular formula, properties of these antioxidants, incompatibility of these products or these antioxidants, their storage condition and the uses of these antioxidants. Then these are the frequently asked questions from this chapter. Define antioxidant and give 6 important ideal characteristics of an ideal antioxidant. List some important antioxidants used in a pharmaceutical formulation. List some important antioxidant used in pharmaceutical preparation. You just have to name the official antioxidant like a hypophosphorus acid, sulfur dioxide, sodium bisulfite, etc. The next is write a mechanism of action of antioxidants, then give the molecular formula and uses of sodium nitrate, sodium thiosulfate, give the mechanism of action of and criteria for the selection of inorganic antioxidant, criteria for selection of inorganic antioxidants. At this place you have to write the ideal properties, define antioxidant and classify antioxidant with suitable example, and write a criteria for the selection of inorganic antioxidant. Give the properties, molecular formula and uses of any of the antioxidant from chapter can be asked. So prepare well all these questions.